everybody. Today we're at historic Mill Creek Discovery Park in Mackinaw City, Michigan, and we're going to check out the Sawmill demo. So join us.
Here is our Sawpit area. Every hour on the half an hour we do a round of double demonstrations where we start here in the Sawpit, talk about how they used to cut wood into lumber by hand before we move on over to the sawmill and see how it was done using the power of water. There are two main reasons why we have this part of the demonstration. The first is to provide perspective on how much easier water power is than manpower. And the second is to relate this over to our other site, Colonial Michilimackinac, a wooden fort over in Mackinaw City. So that fort originally existed between the year 1715 and 1780, which was prior to the existence of any sawmills here in this region. So they had to acquire all of the lumber for building the fort entirely by hand. Now, how this would happen is the commander of the fort would either send out a detachment of soldiers into the woods to start cutting trees into down to turn into lumber, or he would hire some of the many locals from the surrounding area to do the same. And they would initially, in the early days of the fort's existence, cut these trees down with an axe like this one here. This here is called a felling axe, named so as that is its primary purpose, is to chop or fell trees down. And once they cut them down, they would then separate them into 10 to 15 foot logs before bringing them back to a work site like this one. Once they brought them to their work site, they would then start processing these logs into usable lumber for the fort, starting with a task known as hewing or squaring the log. That is where you take axes and you cut the sides off of your log until you are left with a square beam. Now you can see we have a beam here, or log, that's up off of the ground, and on top of what are known as saddle blocks. These saddle blocks provide the crucial dual purpose to hewing of safety and convenience. Convenience is for their tools. If they left the log on the ground, they would inevitably cut through the sides of it and get their axe heads embedded in the rocky, sandy soil that is so common here in this region. Not wishing to dull or damage their blades quicker than they needed to, and thus needing to use some of their limited supply of metal to repair or replace them, they instead opted to get their logs up off of the ground on top of the saddle blocks to create a degree of separation between what they were cutting and the soil beneath them. Now, as far as safety is concerned, it is once again to prevent the logs from being on the ground. If you leave the logs on the ground, you have a round object on a flat surface that you can't easily secure it to. And so you would have a risk of your log rolling while you were swinging sharp axes at it, which it typically isn't advisable for personal health. And so what they would do is use these saddle blocks as a nice wooden base to which they could secure the log using a tool like this one here. This here is called a log dog. It's essentially just a big iron staple where they would hammer one spike into the top or side of their hewing log, the other spike into the top of the saddle block beneath it, and then do the same thing on the opposite end, just as we have done, which secures the log and keeps it from rolling or shifting around. Once they have the log up off the ground and secured, they could then start hewing by taking their felling axe and climbing up on top of the hewing log. Once up here, they could then start cutting notches into the side of the log, separating it into easier to work with sections. We're just going to put one notch in here for the demonstration. Be advised, there is a little bit of a splash zone involved with the process, so if you see any wood chips flying around, just duck. It hasn't taken anybody out yet. Now that we have the notch in there, we can hop on down and hew this section off the side of the log. To do so, we're going to use an axe like this one here. This here is called a broad axe, named so for the axe head being wider or broader than the typical felling axe, and it's designed specifically for this part of the process. On one side of the axe head, it's completely flat and smooth, giving a cleaner, straighter cut than what they could do with a full wedge. And the handle is angled up and away from the axe head. The handle here, with that angle, is once again to serve that dual purpose of safety and convenience. Safety is for their hands and keeps them from bashing against the side of the log as they're hewing and damaging their knuckles or fingers. Now, convenience is for the opposite reason. The axe head is actually closer to the log because of the hands being further away. And so when I am standing along the side and hewing these sections off, it means that I can swing the axe straight down and get the axe right where I need it to be to get that good clean cut. Now what we'll do is we'll hew this section off using the broad axe. And once we finish with that, we'll head on to the final station here in our saw pit area. There we go. As you can see, it did not take that many swings to hew that piece off the side. In fact, a skilled or experienced woodsman of the time could actually do so in about 2 to 3 strokes of the broad axe. That means they could hew an entire 10-foot beam out of a log in about 45 minutes or less. Once they had their beams hewn out, the next step of the process was to take those beams and cut them into boards. They would do so at a station like this one. This here is called a trestle. You can see we have our beams sitting up on top of it. And that is for demonstration so you folks can see what's going on. What they preferred to do in the 1700s, however, is actually dig a deep, long pit in the ground known as the saw pit, as it was easier and safer and more convenient to roll their beams over the top of a pit rather than lifting them using manpower and pulleys onto a trestle like this one. The only time they'd use trestles is if the ground was too hard or sandy to dig a proper pit into, and they would then have to use sawhorses. Regardless of the way that they were suspending the beams, they would cut their boards out of them using a tool like this one here. This here is called a pit saw. It is operated by 2 individuals. The tiller man up at the top and the pit man down at the bottom. As you can see by the saw teeth here all being angled downwards, this blade only cuts on the downward pull. That is so gravity is assisting the cut rather than making it more challenging, but it does mean that the 2 people operating this saw blade have an imbalanced workload. The tiller man up at the top is only responsible now for steering or guiding the blade to make sure it cuts straight and lifting the blade up after every downward pull to reset it for the person on the bottom. That person, called the pit man, as the name implies, is down in the pit. They are the ones actually performing the cut by taking the handle at the bottom of the saw blade and pulling it down into the cut like so, doing that squat every time to maximize how much of the blade they are using. Now that is a lot more work than what the tiller man is doing, and they would become exhausted much more quickly. I'd imagine a lot of people probably didn't like being the pit man back then, but somebody had to do it. And that brings us to now. You can see how there is only one of me here in our saw pit area. So in order to complete the demonstration, I will need a volunteer to be my pit man.
I'll do it.
All right, come on up. I will stand at the bottom here, and I will climb up top. Okay. When I say down, just pull straight down. Down. Up. Down. Up. Down. Up. Down. Up. 3 more. 1, 2, and 3. There we go. Thank you very much. As you can see, it is quite a bit of effort just to cut a few boards out of a beam. In fact, 2 people operating a pit saw like this will only be able to cut 14 to 15 boards in an 8 to 10 hour workday. So they had to put in a lot of work for not a lot of payout. Now before we move on over to the sawmill, does anyone have any questions for me about our saw pit here?
Our family barn was made in 1910, and my great uncle had the blood axe and cut all the logs.
Yep.
And he bored the holes and made the pegs, so the whole barn never had one nail in it.
Yeah, and that was actually a good way to build barns, because they are exposed to a little bit more humidity and moisture than what you would have in a more insulated house. And so nails tend to rust, and it will rot the wood out if that rust comes into contact with the wood. So wood joinery is actually better for a longer lasting structure when it comes to something that has a bit more exposure to elements. And it'll last almost forever. In fact, the wood joinery in our sawmill is 40 years old, and it has not had to be replaced at all in that entire period.
Good.
So, any other questions? All right. Well, that concludes our saw pit demonstration, folks. Thanks for coming out. What I'll have you do now is head over across the bridge to the sawmill, where Mitch, the other millwright, will show you how much better water is at this job than we are. So, welcome to Mill Creek and welcome to the Mill Creek Sawmill. My name is Mitch Fry, junior millwright here at Mill Creek, and welcome to our lovely sawmill. Now, unfortunately, this is not the original mill that Robert Campbell himself built back in the 1790s. This mill was recreated in 1984, and I'll talk a bit more about that later. But right now, the sawmill that you are seeing here, while it is not the original, we like to believe it's a fairly faithful recreation of what Robert Campbell himself built here in the 1790s. He built it on his farm back in the day, where he grew several things, such as apples as well as hay product. He built the mill here initially because of the fact that over on the island, during the American Revolution, they had moved over from the mainland to the island, and they hadn't been able to complete it during the war when it was British held. And so once they got to a certain point during the in 1783, they stopped working on it as this entire area became part of the United States. So they left it partially completed and left it to rot for 10 years until the Americans finally showed up to take control of it. Now, a year after the war ended in 1784, the war ended in 1783. A year later, Robert Campbell acquired this land to build his farm on, and he realized that once the Americans started coming in, they're going to need a source of lumber to help build their homes, businesses, as well as rebuild the fort. So this is why we have our mill here. Now, the original mill was decommissioned in 1839 once it was no longer deemed profitable. This is long after the Campbell family had moved on from here. The mill was decommissioned, taken apart. Some of it was left to rot, while the rest of it was reused for other construction projects here in the local area. Now, the mill that we are currently standing in was reconstructed in 1984, using documentation found both within the local area as well as documentation from abroad, including a book called The Young Millwright and Miller's Guide, published in 1795 by a man named Oliver Evans out of Pennsylvania. And we'd like to believe that this mill is a fairly faithful recreation of what once may have stood here, though for much of the records for Robert Campbell's mill are very much lacking. Much of our mill here that you see before us is built off of ideas of what we know was made by the original sawmill, so we had to go off of that with addition to the plans that we acquired through the Oliver Millwright's Young Millwright's Guide. Oliver Evans' Young Millwright and Miller's Guide. Now, this mill is what is known as a water-powered sash sawmill, which would have been in use here when Campbell was in operation. The reason why it's called the sash saw is because just like a window sash, our saw here operates using two tracks with a saw frame with a saw blade suspended in the middle, whereas a window sash, which is the movable sections on the window sash is guided along two tracks with a large wooden frame with internal joinery or glass panes inside of it, just like how our blade is inside of our saw frame, thus making it a sash saw. Now, our mill is a creek-based mill, which is a little bit different compared to a riverside mill. Our river mill usually has a large water wheel harnessing the force of the river to power everything. We, however, as a creek-based mill, don't really have the same level of water flow through here as a river mill, nor do we have the same level of consistency. For the most part, our
mill can only operate for a short period of time during the spring and early summer, for about 3 to 4 months out of the year. During the spring snow melt, without the spring snow melt, we can barely get enough water through our creek to power this mill for 3 to 4 hours on a every so often basis. So when this mill wasn't operating at peak proficiency, it could generate about 400 horsepower, running 13 to 14 hours a day. This saw blade would be going at about 100 to 120 RPMs a minute, and this mill could turn out anywhere between 150 to 200 boards daily, which is 10 times what you're getting from a Sawpit. Now our mill here, because we don't get a lot of water, we need to supplement what water we do get with the force of gravity. This is where our dam comes into play. Now the dam serves two purposes. The first is that it builds a nice large reserve of water for us to work with as water comes down from Stigman's Marsh to form a mill pond. In addition, the dam raises our water level significantly, allowing us to increase the amount of drop our water will have to do in order to reach our water wheels. So thus, because it has to drop more, we can increase the amount of force gravity can apply to our water, increasing the amount of force our water can generate as it hits our water wheels, thus increasing the amount of energy we can get out of it. Now, the way the system works is water will come down from the dam using the big wooden trough we walked over on the way here, called the sluiceway, which is controlled using a gate using the rope and pulley system you can see outside the window. Once that gate is raised, water will come rushing in to fill a big 10-foot tall box beneath our feet called the crib, which contains about 1,800 gallons of water, or as I like to put it, a lot of bathtubs. Once filled, I will turn this wheel here, which will open a small gate at the bottom of the crib, releasing all 1,800 gallons of water directly onto our main water wheel, known as the flutter wheel. Now the flutter wheel, once the water hits it, will begin spinning like so, generating torque, which will then pass through a rod to an arm called the pitman arm. The pitman arm is named after the same position over at the saw pit, as they both will perform the same task. As the flutter wheel turns, the pitman arm will be going up and down like a piston, causing our saw to go up and down as they are connected to each other. So as the pitman arm goes up and down, so will the saw, getting our blade going, but we aren't actually cutting anything yet, because in order for us to cut something, we first need to move our log and the carriage upon which it sits forward into our saw to make it work. To do that, we actually need to take some of the vertical momentum from our saw here, turn it into a horizontal driving momentum, and transfer that energy into our rag wheel back there. To do that entire process, we have an ingenious system of arms, levers, and beams above my head, all designed using right angles of geometry to create a ratchet that will transform the vertical momentum into a horizontal momentum. How this works is, as the saw is going up and down like so, this arm here will act as a lever going up and down on one end, causing a rocking motion on this side, where this beam here will act as a fulcrum, rocking back and forth, causing this peg to then swing to and fro, thus dragging this arm backwards and forward. This arm is important because this will be the main method of transference between here and our rag wheel. By engaging this lever here, the arm will drop behind me. At the other end of the arm, the big metal hand called the iron hand, which will rest on top of the gear on our rag wheel in some gear notches. Now, when this arm gets ratcheted back by our system, that hand will move back one gear notch on the rag wheel. Then once the arm is set forward again, that hand will push forward and down on the rag wheel, causing it to rotate. That rotational effect will then be passed along the axle to both sides of the log carriage, where there are two small pairs of gear underneath the carriage that interact with these big wooden teeth you see down here, which will then push our carriage forward along the rails into our saw. That will get us cut. Now, once we finish cutting, we need to then reset our saw by bringing our log carriage back towards the wall and ensuring our saw blade is safely outside of our log and in this big notch here. Many similar sawmills on the eastern coast at this time were actually automatic, meaning that you could set up these machines to actually do all the forward and backwards on their own. We, however, because we're out in the boonies, we can't make something so complicated, so we have to do this by hand out here. To do this, we will disengage this lever here. That frees our rag wheel, and then I'll close the gate to the bottom crib, stop the flow of water wheel to our flutter wheel, and thus stopping our saw. Once that is done, water will then enter our big wooden sluice system again, where I can then pull this lever, opening a small gate leading down a ramp to a second water wheel, known as the tub wheel. Now, as water hits the tub wheel, it looks like an old wooden propeller or water turbine, so as it hits, it'll begin spinning like so, generating a vertical rotation, which will be passed along an axle to a gear called the lantern gear. It can be seen right down there in some of the wooden openings over here. That here looks very similar to a old wooden snare drum or a old-fashioned wooden lantern with 2 wooden discs and a bunch of wooden rods in between. The lantern gear's job is to interlock its rods with these teeth here on the rag wheel, allowing the transference of rotation from our tub wheel to the rag wheel, thus bringing our characters back to the reset point. Bring the 2 into contact with each other. I will take this lever here, bringing it down, which will swing an arm with the lantern gear attached into contact with the rag wheel, thus bringing the rotation to the rag wheel and bringing our characters back to the reset. Once I reset, we will unpin the log, and using a long object, we will use these big pegs here to act as a point of leverage to help leverage our log into position. That being said, hope I haven't left you all too terribly bored with all that. I know it's a little bit complicated, but don't worry, there's no test after this, so you don't have to worry about trying to remember it. So, with that being said, let's see this thing in operation, shall we? Using this handy dandy magical button I have back here, I will raise the sluice gate, allowing water to come rushing in to fill the crib. Once the crib is filled, water will then begin spilling over the sides, letting us know that we're ready to do better. Alright, here we go. Isn't it? All that is done using the power of water, gravity, and a bunch of wooden planks all working together to form a complex machine. When this mill is in operation, it operated for about 30 to 40 odd years, during which time it produced a bunch of the lumber that would go into building what is now today Fort Mackinaw on the island, as well as many of the other historic structures on Mackinaw Island. When this mill was decommissioned in 1839, much of it was left to rot or reused for other projects in the local area for construction in a process known as reclamation. Because after all, why let perfectly good wood go to waste? The reason why it was decommissioned is by that point, much of our area had already been clear cut for several miles, so it's becoming harder and harder to bring lumber here to the mill to cut at a profit. So, it was decommissioned. Now, if there are any questions, please feel free to ask. Otherwise, there's one last part of the demonstration I'd like to show you. I invite you to step out either onto the bridge or onto the observation platform below behind me. I'll run the mill again and you'll see the entire mechanical process happening beneath our feet. Alright, so, we don't want to focus on here. You see our flywheel pivot on, that's the power of the entire mill. Then from up here, on the little spot, we'll focus on our water here. So that being said, here we go.
So there you have it. That was the sawmill demonstration at Historic Mill Creek in Mackinaw City. We hope you enjoyed.